Hi, this is Dr. Graves from the CSUN Geography Department and geographyplanet.org. Today's lesson is about correlation coefficients. Correlation coefficient is a statistical measure that tells you how much change in one variable is related to or is matched by change in a second variable. So as one thing goes up, another goes up as well. The very first thing that everyone should learn about correlation is that correlation does not imply causation. Correlation does not tell you the direction of the causality. It doesn't tell you which one causes the other. It is also quite possible, if not even sometimes likely, that you get something called a spurious correlation, in which two data sets have this extremely strong or perhaps less strong correlation, and they are unrelated in any way. And there's even a very funny website, I'll see if I can stick that in there, spuriouscorrelations.com or something like that, that shows all of these absurd correlations that are extremely strong. So you have to proceed with caution when you're working with correlations. Still, the correlation coefficient, and I'll talk about two different types, are extremely powerful introductory concepts and tools for doing data analysis, for noticing trends in the data. And they're not all that hard to calculate and to use, but let's proceed with caution and good sense. So what you see before you is the California EnviroScreen data that we have downloaded in a previous exercise, and if not, if you're in my class, there will be a link to this that you can open and follow along. The data has already been filtered so that we can move more quickly. One, I filtered out all of the counties except Los Angeles, and I also went through and filtered out the observations that had not applicable in it, and I believe there's still one more. How do I find that? I press Control F to find in A, find the place where it exists, and then select or deselect in A, just because these are places oftentimes that no data was collected, and it makes it difficult if you have a lot of these sort of blank columns, or you have text like the letters NA for not applicable in a row of data, which makes doing statistics on those columns of data difficult because, well, of course, they're not numbers in there, but letters, and that often causes problems. And the last thing that it's worth checking out is the filter on total population. Again, we want census tracts here, which is what each of these represent, that have some people in them. And so it appears that the smallest population in any of the census tracts that are being considered is over 1,000 people. And so that seems perfectly fine to me. A lot of times these very small and the very large tracts oftentimes function as outliers, and as you're going to see, outliers often cause the correlation coefficient to go down unnecessarily. And so it's always good to check to make sure that you don't have too many outliers, which would cause extreme skewing in the data. There are ways to deal with that if indeed you do have extreme skewing in the data. And that you should remember from an earlier lesson. If you have skewing in the data, there are a couple of things that you can do, one of which is already done for you in this data. What they have done is, for each score So this is an ozone measure, and if we go over here to the data dictionary and look for ozone, the amount of daily maximum ozone, and then they have converted that to a percentile, which you were shown how to do earlier. And the same conversion to percentile has been done for all of these columns of data, most of which are about pollution hazards in each neighborhood. And then over here to the far right, we have some other things like low birth weight, cardiovascular disease, asthma, and then some socio-demographic things like education, linguistic isolation, which is sort of an indirect measure of where immigrants live, poverty, unemployment, housing burden, which is sort of a ratio of income to housing cost. And then this last one is very interesting, which is a sort of score derived from some of these other socio-demographic characteristics, which are challenges to people living a healthy life in each of these neighborhoods. So converting to a percentile is one way of dealing with skewed data when you want to get a correlation coefficient. Another is to rank the data. And so if I wanted to insert a column here, and I could type in ozone rank, I would type this formula equals rank, EQ, and then highlight the number that you want to rank, and then comma, and then the numbers that you want to rank it against, which is the reference array. So I'm clicking back in here. I'm highlighting this entire column of data. I press F4 to freeze that, and then comma 0, because perhaps I wanted in descending rank. And when I press enter, you will see that this census tract here is, among all of these census tracts, it has the most ozone, and then all I need to do is copy that all the way down. And so all of these are tied for what would be second in the list, and there must be, it's 145 down, and then the least polluted places are ranked. They're tied way down here. So that's another way of converting raw data here into ranked data here. And then you can run the correlation on ranks instead of raw numbers. So I'm going to just go ahead and delete that column. So let's move on to calculating correlation coefficients. What I'm going to do is I need to go View, Split, so I can see what I'm comparing. Now I'm going to go to the lower right-hand corner of my block of data. And what I want to do is just to try to get some correlation coefficients, perhaps say on asthma. And this is one way of doing this. So type in an equals and C-O-R-R-E-L, Correl. You can also type in, I understand, Pearson, which is the same formula. So I'm Pearson. And what I want to do is go up here and highlight this entire block of data, not including the column header. I'm going to press F4, which you'll notice, and remember that it puts the dollar signs in there to freeze that array reference, that block of data. Press comma, and then I'm going to highlight the exact same block of data, but I'm not going to press F4 this time because I want to be able to copy this formula to the right and to the left so I can get a correlation coefficient between the percentile, which is a way of ranking the neighborhoods in terms of the prevalence of asthma in the neighborhood, against everything else. But the first thing you always want to do is rank it against itself, or I should say compare it against itself. That way you know you did the formula correctly. And so once I press enter, I'll jump down here and I get a correlation coefficient of 1, which means that 100% of the time as the asthma percentile goes up or down, so does asthma percentile. So it's perfectly correlated against itself, and that way you know you entered the formula correctly. I'm going to press Control Copy, and I'm going to highlight this row of data. And really what I'm interested in is, in many ways, the relationship between asthma and the percentiles in columns M for ozone percentile, O, particulate matter percentile, and Q, diesel particulate matter. I would expect as those air pollutants increase, so does the incidence of asthma in terms of percentile. So I'm going to press Enter and take a look to see what I've got. Now, generally, I don't want to compare percentile scores against the raw numbers. So I could just sort of delete all of these in white, and I did that, and I'm back here, and we see that there's this really strong correlation between asthma percentile and asthma itself, but we should expect that. And so then as I go across here, I see that there is a slightly inverse or negative correlation between water pollution and asthma, but that shouldn't get our attention. One, correlation is small, and two, logically it doesn't fit very well that polluted water would have a great deal of impact on the percentile of asthma sufferers. As we go across, we see relatively small correlation coefficients among all of these things, and the strongest one is actually between percentile for diesel particulate matter at 0.22. And that may not seem enormous to you, but I think it is something to be concerned with. I've clicked on the Home tab, and I'm going to do conditional formatting here. And what I'll do is a red to blue color scale, and so the correlations that are most extreme, and in this case diesel particulate matter, will show up in the darkest red. Those that are in the middle, like ozone at 0.10, are a sort of neutral color, and the most negative ones will show up in the darkest blue. I'm going to repeat this very quickly, but this time I'm going to do it with the raw asthma score. So Corel should work the same. Highlight F4, comma, highlight, return 100, copy all the way across, and then I'll fix this up. And what we see once again is that the relationship between the people that have asthma and the overall score, the count of diesel particulate matter, has the highest correlation at 0.85. Generally, we will find that those percentile scores work out better because they smooth the data and take out the outliers that kind of mess things up. But it's always worth taking a look at both the raw score and the percentile score. The last little thing I'm going to do is I'm going to take this asthma percentile correlation and copy it to the right, which has all of these cultural and demographic and other disease scores, to see how much correlation there is between those things. And I'll take a moment to fix them up. And what you can see here is that the correlations are far stronger between asthma and some of the other diseases, like the cardiovascular disease. Over here, the strongest correlation is this one called population characteristics, which is sort of an index percentile of these other socio-demographic cultural measures.